In the chapter 5, we use left and right sum to approximate definite integral of a function, and if an antiderivative could be found, calculate the exact value using the fundamental theorem of the calculus. So we use left sum and right sum or Riemann sum to approximate definite integral. Now we discuss other methods for approximating definite integrals and procedure for finding exact value of definite integral of many standard functions. Okay, so these methods are called trapezoid rule. These are the special form of the Riemann sum actually. Trapezoid rule and Simpson rule. These are numeric techniques. To approximate the sum value, we use these techniques. Okay. Actually, approximation of the definite integral by left sum and right sum is instructive and important, but not efficient. A large number of rectangles must be used, and many terms must be summed to get good approximation. For example, 100 rectangles must be used. Okay. The trapezoid rule and Simpson rule provide more efficient approximation when comparing the left sum and right sum to define the integral, to find definite integral value. In the sense that favored terms must be summed to achieve the given accuracy. Okay, so in this method, by using, for example, 20 subinterval, 20 not rectangle, because we don't use rectangle, but 20 sum, we can find the better approximation. Okay. In the third part of the next part, maybe in the third part of this section, we will talk about the table of the integral. Okay. So using a table of integrals, we calculate the integrals. So these tables includes a lot of formulas. I will share these formulas with you. Actually, you can reach now on Canvas in the lecture notes. There will be a 3 page, as I remember. So we have several formulas. Okay, it is not possible to recall all formula. Okay, but by using these tables, you can calculate some other integral by using substitution. Okay, a table of integral can be used to find the antiderivative of many standard function. A definite integral of such function can therefore be found exactly by means of the fundamental theorem of the calculus. And using this table, we can combine this table integral with the substitution techniques. Okay, substitution and integral table. I will not give a lot of example to you for these topics. Okay, you can look to your textbook. These are not difficult, but I will try to give you one or two examples in the problem solving hour. So in this course, I will not mention. You have some formulas. By using substitution, you convert your integral to that given integral formula, and you apply this one. Okay. On the other hand, we have a reduction formula sometimes. By using integration by parts technique in general, we obtain the sum reduction formula. If you know reduction formula, you can calculate your integral step by step by reducing the order of the term. Okay, you will understand when you see the example. So you have a sum integral formula to calculate your integral, but it includes another integral. But that integral is similar to your original integral. So you reduce the order. Okay, so this is called the reduction formula. And then in this section, we talk about the applications. So let's look at the trapezoid rule. Quickly, I will give the trapezoid rule. Okay, for the curve As you know, this is subinterval. So this rectangle is the left rectangle. Okay, this is left rectangle. And that is the right rectangle. This is the right rectangle. In the trapezoid rule, we don't use the rectangles. Instead of the rectangle, we use this trapezoid, okay? This is the trapezoid. We use this trapezoid. So the area of this trapezoid is used to approximate the area under the curve. So as you see here, this is underestimated. This is missing part. This is overestimated part. This is more part. But here, this is again underestimated, but this is very smaller when comparing to these two area. So this is called the trapezoid rule. Trapezoid. Engineers use this rule generally to approximate the sum integral if it is not possible. For example, you cannot calculate the integral e to power x square, so you can use the trapezoid rule, okay? So, as a rule, trapezoid, by using the area of this rectangle, actually, this trapezoid we can calculate. So this is delta x, this is f of x1, this x1 or xk, let's say, xk minus 1 xk. So this is f of xk, this length, f of xk, this length is f of xk minus 1. So if you write this area of this rectangle and this area, okay, easily you can calculate. This is f of xk minus 1 minus f of xk. So the area of this triangle is f of xk minus 1 minus f of xk times delta x 1 over 2. The area of this rectangle is f of xk times delta x. So from here we obtain minus 1 over f of xk. Here 1 over 1 f of xk. So this is 1 over 2 f of xk minus 1 plus f of xk times delta x. If you know directly, you can write this formula. There is no problem. So trapezoid rule says, okay, let's write trapezoid rule. FB function defined on the interval, and of course it should be continuous in my opinion. We should look to your textbook. I'm not sure. Okay, so FB on the interval AB. So Tn is this summation, f of x0 plus 2 times f of x1 plus 2 times f of x2 plus blah 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 2 times f of xn minus 1 plus f of xn times delta x over 2, 1 over 2 times this one. Okay, this 2 comes from the second step. Okay, this is the first one. So from the f of xk to xk plus 1, you will have one more f of xk. So because of this reason, this is 2 times f of x1. At the leftmost side and the rightmost side, there is no other term. So these are constant. The factors of the f of x0 and f of xn is 1. So this is the formula of the trapezoid rule, which is approximate when n goes to infinity. Actually, it's approximate the integral from a to b f of x dx when n goes to infinity. So if you use some constant n term, this approximately equals the area of the region under the function, graph of the function f of x. Okay. Let's talk about the Simpson rule. This is trapezoid rule. Let's write Simpson. In the Simpson rule, Again, we have for the one subinterval I will explain. This is our subinterval, okay? This is xk minus 1 xk. So in the left rectangle we have this rectangle. In the right rectangle we have that rectangle. So in the trapezoid rule we have this line. Simpson says choose the midpoint. Okay, this is the midpoint. Actually, you know what is the midpoint? X sub k plus x sub x minus 1 over 2 is the midpoint. Okay. So at that point, sketch the tangent line. This line. So by using the array of the these parts, again this overestimate because this part is more. Okay, this part is the overestimated parts. So this area can give us the good approximation for the midpoint. Okay, so for the from the Simpson method. So actually always here from this figure you can observe trapezoid rule Tn less than and sometimes may equal if there is a line area from A to B f of x dx. So this underestimates the area. In the Simpson rule, we denote by the Sn. Clearly, Sn is bigger than the area. Okay, so if you write the trapezoid rule here, Sn represent the, or your textbook use the Mn most probably. Okay, so let's use the M. So exact area between the trapezoid sum and the Simpson sum. Okay. What is the formula of the Simpson? Let's write that formula. By using that midpoint, actually, we calculate the height. So the area of this region should be written. I try to remember. Actually, you can calculate, but it's not easy for you. By considering this point at the function value at that point, we can calculate. Okay, so let's write the Simpson rule. Let f be function, be definite on the interval AB. Okay, so partition AB into two n subintervals. So because of this reason, I will write partition of our domain into two n subintervals. Why we use the two n subinterval? Because otherwise we have this point xk plus xk minus 1 over 2. If you divide this 2n subinterval, directly this will be x1, x2, x3, etc. So we can compare with the trapezoid rule. Okay, so to easy formulation, we use the 2n subintervals of equal length. What is the equal length? B minus a over n over 2n. Actually, again we use the n subinterval, so that x is the b minus a over n. Okay, here, but the reason we divide the n, x0 and x1 is the subinterval, x2 is will be our subinterval, x1, x2 and x4 will be our subinterval. Okay, so because of this is that x. So let's try to explain. A is x0, x1, x2, blah blah blah, x2, and this is b. Actually, the reason our delta x is, let's show that here, a, b. X2 is, this is delta x, x4, this is delta x, okay? So x1 is the midpoint. x1 is the midpoint, okay? Here we have x1, here we have x3. These are midpoints. Then, as a result, s sub 2n, actually we use the s, but here we write the m. As for the S4, we have the 2 subinterval, but when comparing this one, we have 4 subinterval. So according to this result, I try to write the correct one. Actually, M is a different case. M is the midpoint approximation, midpoint sum, which is Riemann sum. So there's a relation between the Simpson rule and the midpoint and the transposite rule. But in general, we should use the Sm for the Simpson rule. But I'm confused, okay? First of all, we have Mn. This is Mn, that's right. This is the midpoint rule. Is it called the midpoint rule? Yes, midpoint rule. Not the Riemann sum, the midpoint of the interval, but this is a midpoint rule. Okay, so let's note by the Mn. And Simpson rule denoted by the S2n, which is defined as a 2 times Mn plus Tn over 3, okay? So by using this formula, we define the Simpson rule. I'm sorry. So this is midpoint rule. Midpoint rule. And Simpson rule is this summation. So S of 2n, now everything is okay. So S of 2n is this formula, f of x0 plus 4 times f of x1 plus 2 times f of x2 plus 4 times f of x3, 1, 4, 1, 3, okay? And blah, 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 4 times f of x2n minus 1 and f of x2n times delta x over 3. Let's write the 1 over 3 at the beginning, okay? So this is the Simpson rule. So m of n can be expressed as this summation, okay? F of x0 plus x1 over 2 midpoint plus f of x1 plus x2 over 2 plus blah 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 plus f of xn minus 1 plus f of xn over 2 delta x. Here we use the triangle. Actually, we use the this one. This one. Okay. So this is the midpoint. This is the midpoint, this rectangle. If you use this formula, you will find the troposite, this troposite. Okay, sorry, this Simpson. So this area. This is also troposite, but this area. We use this area by using that formula. So this is called the Simpson rule. You can find some example related with the troposite and the Simpson rule in your textbook. Next topic is the using a table of integral. The formulas in the table 1 in the appendix C of your textbook are organized by the categorized, such as integrals involving a plus bu. Let's show that these formulas. Okay, sorry, I could not reflect that formulas. I need some technical arrangement, but I could not do. So maybe I can write one of these formulas to you. For example, according to your textbook, in the table, there is this formula. U over a plus bu plus c plus du equals 1 over a plus d minus bc a over b ln a plus bu minus c over d ln c plus du. Actually, we can calculate this integral easily, but you need to take partial fractional techniques to calculate the integral, but you don't know, okay? So, if you know that formula easily, you can calculate this integral by considering this formula, okay? In the final exam, generally, I don't ask this type of the questions, but maybe in the homework I can ask, but I am not sure whether or not. So here, this is A, this is B, this is C, this is D3. So by considering that these are 1 over A times D, 5 times minus 3, minus 2 times B times C, C is 4, not 3. So A over B, 5 over 2, ln absolute value 5 plus 2x minus 4 over D is minus 3, ln 4 plus 3x. This is indefinite integral, so let's take the constant term C. So as a result, if you make your arrangement, ln 5 plus 2x minus 4 over 69 ln 4 minus 3x plus c is the answer. So by using the formula from the table, you can calculate the integrals. But sometimes the given formula and the your function can be different. For example, the given formula is this one. Let's write u square over u square minus a square du integral 1 over 2 u times square root u square minus a square plus a square ln u plus square root u square minus a square plus constant term c actually, okay? So this is the formula from your table in your textbook. I don't know the number of this formula, formula 44, okay? So according to this formula, let's try to calculate this integral. X square 16x square minus 25 dx. Maybe without using substitution, you can calculate by taking 16 common factor parentheses, etc. You can calculate, you can write in that form by obtaining the constant term. This is correct, okay? This is the one way. That's right, this is the first way. But generally, we need the substitution, okay? This is easy. So without using substitution, you can calculate by taking 60 common factor parentheses 4 x square minus 25 over 16 dx. So this is 1 over 4 integral x square over x square minus 25 over 16 dx. So here a is 5 over 4, okay? So here a is positive actually. In the formula it is written. So a is 5 over 4. Directly you can use this formula. But if a is negative, there is no problem. Always we have a square as you see. So this equals 1 over 4 according to that formula. 1 over 2 x square minus 25 over 16 plus 25 over 16 ln x plus x square plus, not plus, minus 25 over 16 again. Okay, plus c. So this is the answer. You can make some arrangement. But as a second way, let's look. By using substitution, we can give the response to our question. Our integral is this one, x square over 16 x square minus 25 square dx. Okay, so let for x be u. So if for x be u, clearly 16x square will be u square. In the formula we have u square, okay? So this implies 4 dx is du. So du is dx over 4. So this integral equals, instead of the x, we should write u over 4. Okay? So instead of the x, I wrote u over 4. U over 4 square over, this is u square minus 25. And dx is from here, dx is 1 over 4 du, okay? So 1 over 4 du. So now from here we obtained that integral. 4 square is 16 times 1 over 4 is 1 over 64. Yes. So 1 over 64 integral u square over square root u square minus 25 du. Now you can use the formula, given formula, this formula here. A is 5, okay? So in this case, A is 5. So as answer, 1 over 64 we have 1 over 2 u times u square minus a, u times u square minus a square 25 plus a square plus 25 ln u plus u square minus 25 plus c. Let's check one more time. Okay, that's correct. So this is the answer of this integral, but our variable is x. So we should turn back to our original variable. U is 4x. So from here 1 over 64, 128 maybe we can write. 128. U is 4x. So 16x square minus 25 plus 25 ln 4x plus 16x square minus 21 plus c. So this is the answer, okay? Here we need the parentheses. If you compare that one, you will see the same thing. If you multiply the 16 etc. here, you will obtain the same result, okay? So this is called the substitution and the integral of the table, okay? If you know the sum integral, you can calculate. And last one is the reduction formula. For the sum integral, we have a sum reduction formula. For example, we have this. This is obtained by integration by parts. U to power n e to power au du equals u to power n e to a to power u over a minus n over a u to power n minus 1 e to power au du. This is a. Okay. So if you want to calculate this integral x squared e to power 3x dx, by using this reduction formula, you can calculate the right side. Here n is 2, a is 3. U square e to power 3u over 3 minus 2 over 3 u to power u is x, sorry, not u. You should write the x to power 2 minus 1x e to power 3x dx, okay? So by this formula, we can write easily this one. N is 2 here. N is 2, a is 3. Now, we obtain the similar integral. N is 1, a is 3. So for this integral, again, we can use this formula. So let's repeat first of all this part, okay? So x squared e to power 3x over 3 minus 2 over 3. For this integral, I will use this formula. N is 1, so x e to power a is 3, 3x over 3 minus 1 over 3. Integral n is 1, so x to power 0, e to power 3x dx. And we know this integral equals e to power 3x over 3. So as a result, we obtain the answer, okay? So this is x squared e to power 3x over 3 minus 2x e to power 3x over 9 minus minus plus 2 over 9 e to power x over 3. So this is 27. Plus c is the answer. So by using reduction formula, you can evaluate the some kind of two integral as you see in this question.